This video looks at National 5 chemistry questions. Specifically, we are going to be looking at we're not looking at percentage bonus, sorry. Specifically, we are looking at the charge on an ion in a compound and how we can write the ionic formula. So a good place to start is looking at the worked example. So in terms of writing the ionic formula for magnesium iodide, it's very similar initially as writing the compound formula for a molecular compound. So first we must find the chemical formula of the ions we're using. So magnesium has the atomic symbol Mg and iodine has the atomic symbol I. We then look to find the valency of these ions. So in terms of these, so obviously if we look at our data booklet, we can go up to magnesium, and it's not a great orientation to look at it, so we'll just go down a little bit more. So magnesium here, you can see it is a group 2 metal. So if it loses 2 electrons, it will have a full outer shell, and it will have the electron arrangement of neon. So it will have a 2,8 from having had a 2,8,2. So magnesium's most common ion for us will be magnesium 2+, which means for us it has a valence of 2. And iodine, if we look at the table here, iodine is going to need one more electron to take it from the electron configuration 2,8, 18, 18, 7 to xenon's electron configuration, which is 2,8, 18, 18, 8. So its most common ion will be a 1 negative ion, and in this case that will give it a valency of 1. So you take the common charge on the ion and you remove the sign, and that will give you the valency. So in this case, magnesium has a valency of 2, iodine has a valency of 1. And we're going to use the classic symbol valency swap, simplify, drop motif, so SVSSD. So we've written the symbol for magnesium and iodine, we've written the valency underneath, so 2 and 1. So our first S will be swap. So we're going to swap the valency of iodine over to here and the valency of magnesium over to there. We'll then simplify. In this case, we can't simplify it. 1 and 2 are as simplified as they go, and then we'll just drop it down. So you'd have magnesium with a 1, so we just simplify that by not putting a number in at all, and iodine with a 2. Now this would be how we would do the molecular formula. We've been asked for the ionic formula. I would tend to do this first because it's relatively simple to convert this into the ionic formula. What we will do is we will put a bracket around magnesium and a bracket around the iodine. Now you see I'm pushing that 2 out to the right hand side of the bracket there. So the reason I'm doing that is that we've already discussed the fact that magnesium will have a 2+ charge on its ion, so it'll be a magnesium 2+ ion, and we will put that into the brackets here. And iodine is a 1 negative ion, so we'll put that, the charge on the ion, into the brackets there. And what we can see from doing that is that when we look at the ionic formula for magnesium iodide, we have 1, because of the valency being 1. We have 1 magnesium 2+ ions, and then we have 2 iodine 1 negative ions. So the important thing here is that overall magnesium iodide has no electrical charge. So the positive 2 from the magnesium ion is cancelled out by 2 of the 1 negative ions here. So we've just worked that through, and you can see that the answer we've just come up with there is the same as the one we have here. So once we had our chemical formula, we push the 2 out for the iodine, we put the charge on the ions in, and then we are done. So a slightly different way of doing this, these questions cover the past papers back to 2014. So it's got a few different kinds of questions in it. We'll come back to ionic formula in just a second. So the charge on the manganese ion in manganese dichromate, this is one that a lot of students find quite tricky, but it's actually relatively simple. So we're trying to find the charge on the manganese section here when it's paired with the dichromate ion. The important thing to remember here is that, again, just like up here, there is no overall charge on manganese dichromate. Whatever the dichromate's charge is, the manganese is able to, just one copy of it, is able to balance that out. So what we do is we go to our data booklet and we're looking for the dichromate ion. So the dichromate ion is on page, group ions are here. So the dichromate ion is here, dichromate, and it's Cr2O7. And if we want, we can just double check, Cr2O7, yep. It tells us at the top here that dichromate ions have a 2 negative charge. Now, so the dichromate ion, I'm just going to bracket it here so we can see it. There we go. So the dichromate ion here has a 2 negative charge. Overall, manganese dichromate has no overall charge. So for that to balance out, the manganese is going to have to give us a 2 positive charge. Overall, no charge. So a 2 negative is balanced out by a 2 positive. Okay. Just making sure that's back to where we were before. Good. And it's a little bit speedier from here on out. So write the formula for potassium dichromate showing the charge on both ions. So this is like the worked example. So we take potassium, we go to the data booklet, we find out that it is a group 1, so it has a 1 positive charge. So we would give it the 1 positive. And the dichromate ion, we've already seen that it has a charge of 2. When we swap that and drop it and put it in, that would give us K2, and it would just give us the dichromate ion on its own. We've already said that potassium ions have a 1 positive charge, and the dichromate ion, if you're struggling there, it is just written out for us here. So the dichromate ion is Cr2O7, and it's got a 2 negative. Again, for that to balance out, so for the 2 negative charge of the dichromate to be balanced out by potassium, which is only a 1 positive charge, you will need 2 of them. And it's just important that we put the 2 outside the brackets here, and we have these nice curvy brackets. Which of the following does iron have a 3 positive charge? So although the first 2 questions were different in terms of how they were written, they were quite similar in how we ended up doing them. So which of the following compounds does iron have a 3 positive charge? So you may used to use the data booklet. If we look at the data booklet, it will tell us that oxygen needs 2 electrons to get a full outer shell, so it will have a 2 negative charge. That means that, again, overall, iron oxide has no charge, so the iron must have a 2 positive charge. Phosphorus, if we look at the data booklet, it needs 3 more electrons, so the ion for phosphorus will have a 3 negative charge, which means iron will have to have a 3 positive charge. So that'll be correct. Again, just for completeness, so the NO3, if we go through the data booklet, NO3 is the nitrate ion and has a 1 negative charge. So if a nitrate ion has a 1 negative charge, we've got 2 of them, that will give the right-hand side here an overall 2 negative charge. So in this case, iron has a 2 positive charge. Again, in terms of the phosphate ion, when we look, it has a I'm great at finding things. Here we are, 3 negative charge. So the phosphate ion has a 3 negative charge. We've actually got 2 of them. So that will give the right-hand side an overall 3 times 2, 6 negative charge. So what does the charge on each individual iron have to be for 3 of them? Let's got 3 here. To give us a 6 positive charge. If the right-hand side, these 2 phosphate ions give us a 6 negative, the left-hand side has to give us a 6 positive. So 3 times 2 would give us that. So only B, the one I've already read it out for the answer, will be giving us iron with 3 positive charge. The ionic formula for potassium permanganate, so we find potassium in the same way that we did up here, has a 1 positive charge, it's a group 1, so we'll bracket it, the K plus ion, and then the manganese ion, we can go in here and we can find it. So here's permanganate, MnO4 negative. So again, the data booklet's actually telling us that the ion has 1 negative charge, which means that for it to be equal, for the overall thing to have no charge, the potassium has to have a 1 positive to balance out that 1 negative. Write the formula for potassium chlorate, ClO3, showing the charge on both ions. We can do it either way. We can already know that potassium has a 1 positive charge. So when we look at chlorate, we can't do it both ways. We have to just know that potassium has a 1 positive charge. So the chlorate ion here must have a 1 negative charge. In this case, there's 1 chlorate ion and 1 potassium ion, so there's no need to put numbers outside the brackets. Write the formula showing the charge on both ions for barium sulfate. So they had a wee run of doing that in 2019, 20, and then 22. So barium sulfate, sulfate ion, you can go to the table for this one. Sulfate ion is SO4 2 neg. So put that in here. A single barium would therefore have to have a 2 positive charge to balance it out. And again, it's just 1 sulfate ion and 1 barium ion. Calcium carbonate, we go to the data booklet, it will tell us that it has a 2 negative charge. And calcium is a group 2 anyway, so we know it has a 2 positive charge. Overall, calcium carbonate has no charge. So if the carbonate has 2 negative, the calcium will have to have 2 positive. And similarly, if the calcium has 2 positive, the carbonate has 2 negative. In this case, they haven't, just like the one up here, they haven't given us the formula for the carbonate ion, the sulfate ion, so you just have to work it out or note from the data booklet. The charge on zinc ion and zinc dichromate. We're getting good at this here. We go to the data booklet. We find the dichromate ion is in this column here, Cr2O7 2 neg. And that means that the zinc has to have a 2 positive charge. Again, you can see there's no balancing numbers in here. So we've got 1 copy of zinc and 1 copy of the dichromate ion. The charge on the chromium ion in this. So we can go to the data booklet and it will tell us that chlorine is in group 7, so its ion will need 1 more electron for the atom to become a chloride ion and get that full outer shell. So 3 of them, because remember the chromium is this left-hand side, so the chlorines on the right-hand side that I haven't shaded in, they'll have a 3 negative charge overall. So we've got a chloride ion with 3 of them, and then the chromium will have to have a 3 positive charge for this to balance out. Ionic formula for the compound iron 3 oxide. So you're going to have iron with a valency of 3, so 3 positive charge. Oxygen's got a 2 negative charge, so that's not going to work. So quite often in chemistry it comes down to making one side come to 6 and then making the other side come to 6, especially when we do ion-electron equations. So oxygen, if it's got a 2 negative charge, you'll need 3 of them, and then you'll need 2 irons so that both sides balance out. 6 negatives on the right, 6 positives on the left. And then the charge on zinc in the compound zinc phosphate. So again, we go to the data booklet, it tells us phosphate ion is a 3 negative, and the zinc ion is a 2 positive. So in this case, 3 zincs will balance out 2 phosphates. The phosphate ion is a 3 negative, and there's 2 of them, so it will give us a 6 negative. So what does the charge need to be on each zinc for 3 of them to balance that out? The charge will have to be 2, so it's 2 positive. It's just practice. When it says ionic formulae, which is what most of these are about, that's what we do. Obviously, there's occasionally they ask what's the charge on the ion in the compound, but for the most part, it is this kind of write the formula stuff. The final one, write the ionic formula for potassium nitrate. So we go to the data booklet. Nitrate ion, 1 negative charge, but also we just know from the data booklet that potassium is a group 1 metal, so it'll have a 1 positive charge. It's just about making sure the ion with its charge goes inside the brackets, and if there's multiple copies of that ion in the compound, for example in potassium dichromate, then we put that outside the brackets. Okay, hopefully that was useful. If there's anything else you want to ask, please get in touch with your teacher.